Hey doses, what's up and welcome back to another video. Today we're going to be talking about deriving function, the basics of deriving functions, just the basics for now. We're only going to be focusing on the basic formula and doing some questions on it. So let's get right into today's video. So you're asked to derive. That means you're giving obviously a function and you're asked to derive. Let's say you're asked to derive once. That means you're trying to find f prime of x. F prime of x is the first derivative. The second derivative will be f double prime of x. And then so on and so on. You just add on more apostrophes for the more derivatives that you do. But to find f prime of x first, right? This applies to all formulas, but just for f of x to f prime of x, how would you do that? Well, there are two ways. The first way is the first principle, right? Which we talked about in the videos before. We can use the first principle to find derivative. Or second, and the most preferred option is this option. Unless specified in the question to use the first principle to perform a derivative, please use this formula over here. This formula is goated. It's so good. It's actually the best formula that's ever been invented. Like the first principle is nothing compared to this. And I'll explain. So let's say your f of x is, in this case, x to the power of n. This formula states that to find f prime of x, you don't have to go through all of plugging in x to the power of n into the first principle. Instead, you just know that f prime of x, the first derivative, is nx n to the power of n minus 1. That's all you need to do. And it'll make more sense once we do more questions. So in this case, you've been asked to derive 3x squared. Derive 3x squared, you have to consider f of x is equal to 3x squared. But in this case, we're not given the function f of x in the form of x to the power of n. We have a variable over here, which is our 3. Our 3 is over here, which we do not like whatsoever. So how are we going to deal with this? Well, to deal with this, it says that if is a rational number, we just check that first. Yes, n is a rational number. And this 3 over here, it is also rational. And since there's no variable, it's attached to the variable. It alone, it doesn't have any variable. If it was written as 3x times by x squared, that would be a different issue. But in this case, it's not given as such, right? So this means that we can negate this value over here and focus on this. So I want you guys to focus on the x squared. So f of x is now just x squared. Remove the 3 out of your minds. So f of x is just x squared. So f prime of x, using our formula, we bring down, what do we do? N x n minus 1. So we do 2 is equal to 2x 2 minus 1, which is 2x. Now remember that we still have to plug in it into the 3 over here. So now our actual f prime of x, right, will be 6x because 3 times 2x. Let me just write this as v of x instead of f prime of x, so v prime of x. There we go. That makes it a little bit easier. There we go. We got our f prime of x. Now let's do one more question so that we understand it better. So in this case, we've been asked to derive 8 times 36x squared. So there are different ways to approach this. Now you have two variables over here. Either one way you could derive individually, which we'll talk about later, so I don't want you to do that right now, or you could just consider it as 8 times 36 times by x squared. Because this 8 and this 36 are both rational numbers, and they're attached to the variable but don't have a variable to themselves. And if we can bring them out, bind them into one variable, we don't have to calculate this right now. But if we do, let me just bring out a calculator. Actually, why do I need a calculator? I'm just a G. Let me just do it in my head. Yeah, I think it's 288. Yeah, totally did that in my head. So if we just combine those two and multiply them, even if you don't know the answer, you can do this, and you can put 288 times by x squared. And now in this case, even though the number is bigger, it's the same as this squared and 288x squared. So again, we can consider our v prime of x, our v of x, right? Just write that better. So this is our f of x right now. F of x is equal to. So our v of x right now is equal to x squared. So our v would naturally just be 2x again, as we saw from our past equation. So our f of x we're considering as 288, right, times by v of x. So naturally, our f prime of x should be 288 times by v prime of x, because this is the v of x is the only one with a variable. So this is what we're considering here. So that means 288 times by 2 times by x, which is, do that in my head real quick again. 288 times 2, I think it's somewhere around 576, 576x. That is our value. Bam. This might be a little bit confusing, but this is the method that I use to visualize it at least. And you might find it simpler to just do it in your head. But once you more complicated formulas like when you have multiple variables to differentiate in the same equation, it helps to visualize it like this, like f of x, v of x. And I find it easier to do when I do it like this. Again, there is some homework left for you guys. I will be sharing the slides with you, so please do check that out in the description below. And definitely do these, definitely help. And this one's a little bit of a tricky one, so go ahead and try to solve this one. And the mark scheme is given on the next slide. Thank you so much for watching today's video. I hope you have a good one. Take care.